This this video is to talk a little bit about a couple of documents that are on, or a couple of files that are on the wiki here for reviewing about distributions, the stuff from the chapter on discrete distributions. And the first one is this Microsoft Word file called Discrete Probability Distributions, and it starts by talking a little bit about the random variable, some of the parameters in here, so that these distributions we're looking at are actually just families of distributions. For example, there's a binomial for every choice of n and p gives you a different binomial, for example. The probability density function, or PDF, or PMF, probability mass function, it talks a little bit about that, and the CDF as well. Talks a little bit about the formula for the mean, the general formula for expected value of x, the variance and standard deviation, even gives you a formula for the skewness. And so all of this stuff is on some of the earlier lectures, but that just kind of summarizes it here in more of a narrative form for you to read. It also talks a little bit about some calculators and computer software, and it talks about a Bernoulli trial. And then we have some examples and classes of functions, most of which we've studied about already. The first one here is a finite distribution, and here's just an example, and it goes through and computes the graph and the CDF and the PDF and the CDF for it, and graphs it. Computes the mean and the variance, and it shows you how this goes. So this really kind of helps you understand the definition of these things. Then we talk about the Bernoulli binomial distribution next, and it sort of gives you a summary notation for it. Identifies the basic situation, gives you a real-world kind of example you can think of, talks about some parameters that are built in, and then of course this parameter q that's actually something that's computed from the other parameters. It's just 1 minus p, of course. Talks about the probability mass function. We've usually been calling it the PDF in here, but there's the formula for it. If there is a shortcut formula for the CDF, it shows you that. It tells you the mean, variance, standard deviation, and shows you what command to use on the TI-84 or TI-89. Also Excel and Minitab, and then gives you some examples of a few different graphs for this binomial. Okay. Similarly, this talks about a geometric distribution, and it has a nice little formula for the CDF, which we don't normally get, and it talks about some of the different parameters, and also the mean, the variance, and so forth. Talks about those a little bit and gives you some examples there again of the graph. Same information for each one. There's the Bernoulli distribution, which is kind of some of the others are based on, and these are actually 9 different Bernoulli distributions graphed in that picture. And here's the hypergeometric, and there's an example, and it shows you some of these things here. And there's the PDF, and it gives you some of the other characteristics, and then there's a whole bunch of different graphs, a whole bunch of them there for hypergeometric, showing you what some of the different ones look like. And there's one more here that we didn't talk about earlier. This is called a negative binomial distribution. It's kind of a generalization of the geometric distribution, actually. The hypergeometric is a generalization of the or not a generalization of, but a similar to the binomial distribution, whereas the negative binomial is really similar to the geometric. Actually, it's a extension of that, a generalization. So here, remember, in the geometric distribution, we completed we did our Bernoulli trials until we got our first success, and you count the number of times it takes you to get there. In a binomial distribution, you are looking for a fixed number of successes, R successes to occur, and you count the number of failures. So this is if R is 1, this is almost the same as a geometric, except X would be the number of failures, not the total number of trials. And so this one counts the number of failures until you get R successes. So R could be, say, 5, and you count how many successes, how many failures it takes you until you get your 5th success. And anyway, this is similar to the thing that we did for counting, well, some of our counting things here. So this is has formulas for that as well. And then one that your book talks about that we haven't really had a chance to lecture on this was the Poisson distribution. So anyway, this gives you most of the basic distributions here, and it gives you some summary information so if you want to review that or if you ever want to go back to it. Now let me also talk about this Excel sheet that I put together called probability distributions, and this is for discrete distributions again. And this one talks about Bernoulli, finite, binomial, geometric, hypergeometric, negative binomial, and Poisson, the same ones that were in the other document. But in this one, the shaded background is the parameter that controls everything. You can type a particular number in there, like this is 1/3, but I can make it 1/4, say 0.25, and notice that it changes everything accordingly, including the graph over here. And actually the CDF is actually a bar that goes, it's 0 before this, a bar that goes horizontal to here, and then steps up to here, and it's a bar at 1 going across. So it figures out most of the interesting information. This is a finite distribution here, and it shows you all the steps that are involved in computing the mean, the variance, and even the skewness as well, and the standard deviation. And it gives you a bar graph of that one too. Now, this one is for a binomial distribution, and this particular one is set up where as long as n is 30 or less, it works really well. And you enter in here an n and a p, so if I wanted to enter in, let's say we're going to do 10 trials, and the probability of success is 0.75, it figures out what Q is, what the mean, n times p, the standard deviation, and it figures out a table here, and it should go up to 10. After 10, you'll get maybe some error messages, but this part of the table up to here is your CDF, PDF, and then your CDF over here. And then here's the graph of the PDF. It goes out to 30 here, so there may be some dead space there. If you let n go up bigger than 30, this will just figure out your first 30 bars, and that's all it will do. Now, this one is deceiving here, because this is not really the right thing for the CDF, but it can kind of give you an idea of the CDF. You have the dots along here, and the actual CDF doesn't connect the dots like this. What the CDF really does is go across with a horizontal line, and then it jumps up, and it's a step function. But you can kind of get the basic idea. So this is more like an ogive for this CDF, but it's kind of like the CDF. Okay, so you can take a look and see what that is. But instead of, but it's connecting these across like this way instead. It really should be steps. So this is not exactly right, but it does give you some idea of what's going on there on the CDF. Same thing for the geometric. In the geometric, there's one parameter. Let's say this is 0.6 for this. That means Q is 0.4, and you can find the mean and standard deviation there and so forth, and you can see the graph working out. And again, same thing for the CDF here. It's really a step function. This is not really a CDF. And then hypergeometric. In the hypergeometric, you have several parameters. The ones that you want to change are these right here, 10, 6, and 4, and everything else is generated from that. And so these others. So let's say I have 15. Oh, more usually it's a little bigger. Let's say we got 18 items, and of those 5 or 6 successes, and we're going to draw out 3 of them. Oh, let's make it more interesting. Let's say we got 25 items. We're going to draw. We've got 8 successes, and we're going to draw out 5. Okay, so then our table should go down here to 5. Anything below that's going to give us some error messages, but this is actually set up to go to like 100, I think. No, 200. And so this will work for n up to 200, capital N. And then it works out the PDF and the CDF. and then once again there's the graph of it. And again, this one is not really right. It should be connecting these up, and it should stay at 1 from there. So it should be step function again. So these CDF graphs are not so good, but the rest of it's pretty good there. And then here's your negative binomial. We didn't really talk about this one too much, but again, it tells you what the parameters are. And so say we wanted to find, we want to go until we get 4 successes, and the probability of success is 0.7. Then this figures it out. And like the geometric, this actually goes on forever. So it actually goes on forever past 29, but if you see right here, to the limits of Excel, it's already rounding off to 1. These probabilities are so low. They're not really 0, but they're practically 0. And so there's what the graph looks like. So negative binomial has a tendency to start low, go up high, and then come back down a lot of times. And then, again, these really should be little step functions, but it's kind of smoothed it out. And then you can read your book about the Poisson if you want. We're not going to have any questions over this one, but here's the distribution for a Poisson, and it only has one parameter, lambda, which turns out to be both the mean and the variance, actually. So you put in that lambda, and this is the formula right there, and this turns out to give you the graph and everything you need there. So the point is of this spreadsheet, you can see how you can get in here and investigate how I built this, and can see a little bit about how spreadsheets work, but then also it gives you a nice little thing that you can actually just enter in some stuff, change the parameters, and you get graphs and tables and stuff, and it tells you all about the things like the mean, the variance, the standard deviation, even the skewness. It computes all this for you. So that can be a little resource that can be helpful. Unfortunately, you will not have that resource available on the exam, but you can use that if you have real-world problems that you never need to get hold of. You can come back and do this, and also it gives you a nice visual of getting a whole bunch of graphs real quickly, so you can kind of compare them and see what happens as you change some of these parameters. So there's a couple of resources: the summary notes here, and the spreadsheet here that allows you to investigate some of these different distributions. So I hope that's helpful to you.